So my name is Regina Obe, and I'm one of the members of the PostGIS development team and steering committee. And I'm also an author of several books, which hopefully some of them you've heard of. And I'm working on two new books. Oh, actually, I want to mention the PostGIS Day 23 coupon code for any Locate Press book today. And we had two other authors who presented there. So you should check that out at Locate Press. So I'm working on two other books, which sadly I've said that for the past year, and I gotten a little further, but still quite a ways to go. I'm hoping the second edition of the PG Routing Practical Guide will have done probably, well, hopefully the first quarter of next year. And I'm also the PostGIS Windows maintainer of the PostGIS bundle. So if you've ever seen this application stack builder screen, you're using work I've done. And so the latest PostGIS 3.4 includes many of the extensions that were covered today. And newest in the bundle is the H3 PostGIS extension, which I should mention now supports raster. So it's the very first extension I can think of that actually depends on PostGIS raster also. So it depends on both PostGIS and PostGIS raster. And newer than that is the MobilityDB is now shipping with the PostGIS Windows bundle. And for people who are on Linux or who are on Ubuntu or Debian or some Red Hat derivative, just recently, in the past week or so, the H3 PostGIS is now available on yum.postgresql and app.postgresql. And MobilityDB is still in the works. I don't think it's available in any of those yet, but it's getting close. And so today, the surprise really is what I'm going to cover, what extensions, because there's no way I could cover all of them. So I'm going to just try to go through as many as I can that I think will be useful to people. Okay, so I'm going to skip the boilerplate of my general process of creating a schema to store my data. And the first extension I'm going to cover is PostGIS. And in PostGIS 3.3, the greatest function that was ever created shipped with PostGIS 3.3. And finally, GIS people who are using PostGIS could show other people what exactly is vector data. And not only could you show them vector data, but you could put it on a map. And putting on a map is what we refer to in GIS as georeferencing a vector. In addition to the PostGIS extension, there's another extension called the PostGIS SF Siegel extension. And this one is mostly used for 3D data. And I really wanted to show some stuff, but since the PG admin tool can only show 3D, all the cool stuff I couldn't show, and I didn't want to hoist up a 3D viewer just so you could see stuff. So I'm going to focus on just one of the functions, which is a 2D function, which is the straight skeleton. And let me just get rid of that. Okay, so you start off with, okay, that's the output. So you start off with the original, right? It's the H. And the straight skeleton of that would look like that. And if you put it together, you could see the combination. And this is mostly useful for river banks. So for example, if you want to convert a river into a line string just for easier analysis, or you could take the length of it and things of that sort. And I should mention the PostGIS SF Siegel extension coming in 3.5 has added several more functions. And many of these are 2D. And so there's a bit of a competition between Geo's functionality and SF Siegel. So the PostGIS SF Siegel builds up on top of the Siegel library, which is the computational geospatial algorithm. And so in order to prevent this confusing overlap, because every time GEOS introduces a function and PostGIS SF-SQL already took that name, it just gets kind of confusing. So coming in 3.5, all the SQL functions will be prefixed with CG so that you know that they're SF-SQL and they're not part of the main PostGIS extension. But we'll still keep the old names, but any new functions that are introduced to SF-SQL will only have the CG extension. All right, so the other extension I want to cover, which I think Brian and Reese already covered, is the HTTP extension. And even though this isn't a spatial extension, it's part of the PRAM stack, but it's one of those extensions that regardless what you do in the database, you always find a need for it. Because if ever you want to bring data from the web into your database, it's just the most convenient way to do it. And I'm actually going to combine PostGIS, the HTTP use and PostGIS raster use. So let me just, so the PostGIS raster extension, I should mention the PostGIS raster extension deals with vector data in PostGIS, whereas the regular PostGIS proper extension just deals with vector. And PostGIS raster builds on the GDAL library, which the OGR FDW, which I'll cover later, also builds on. But the PostGIS raster exposes the raster functionality of GDAL. And by default, all the raster drivers are disabled. So you have to enable it either for your section as a one-time, or you can set it globally for your database. You could also set it at the system level, but I usually set it at the database level. And in order to see what kind of rasters you can read, there's this function called, and I should probably put a link to where you can find detail about it. So all the raster functions are prefixed with RT. So the easy way to tell what it is just put an RT in front of it. Okay, so you could see that's kind of the output. So if I were to run it, and the reason why this function is particularly important is not all PostGIS rasters are created equal. And what your PostGIS raster extension can deal with is dictated by which version of GDAL that your PostGIS raster is compiled with. So if you look in the PostGIS full version, it'll tell you what version of things you have here, which is very long, but you'll see a GDAL version somewhere here. Yeah, here it is. So this one's compiled with GDAL 3.73. So I can only do things. And then on top of that, it's not just the GDAL version that dictates what you can read. It also depends on what other libraries GDAL was compiled with. So that's why you really need this function to know what you can handle. So if I were to run this function, I see that I can handle 147 different raster types. And so there are two ways to load data in PostGIS, load raster data. There's the one that was covered, the raster to PGSQL, which is generally what you use for larger amounts of data. But you can also just grab it from anywhere, from any supported raster format. So I'm just going to create this temp table. And I'm going to combine the use of the HTTP extension and PostGIS raster to bring in. And this ST from GDAL raster, it converts this. So this text to byte A function is part of the HTTP extension, and it takes any web content and it converts it to binary form. And then this ST from GDAL raster will take any supported raster format in your GDAL driver list and convert it to PostGIS raster. Okay, so now we've converted whatever this thing is into PostGIS raster format. And I'm just going to do this quick hack that I use often to see what output data looks like. And so it looks like a bunch of, it's a Star Wars stencil set. And so let's unravel this. So the STSPNG function is a function that's built, that's part of the PostGIS extension, but there's a more generic form of that, which is called I think it's from GDAL. And that is not what it's called. Yeah, so if you look in the, I think it's under constructors. No. Yeah, okay, so here's the function. So it's a constructor. It will take, actually, no, it's not. All right, well, I will go back to it. But anyway, there's a more generic form of this. I think it's probably as GDAL raster. Now I'm thinking about it, that would make more sense. Okay, so this one is the more generic form, but since there's so many options you can feed to this, we have more or less very common use that use the defaults and return. So this will return a PostGIS raster into a PNG format. And one of the common uses for PostGIS rasters to do analysis, because if you think about it, you have temperature data, you have elevation data, you have population data that's often shipped as raster format. And so there are all these statistical functions in raster to handle that. And one of my favorite ones is the histogram function. And this function basically takes a raster, it takes a band number, because a raster can have multiple bands, and it takes a number of buckets. So if I want to break this into 3 buckets of data, it tells me the min, the max of whatever this data set is. So this is basically telling us that our Star Wars stencil is composed of 80% white space and about 20% non-white space, which if you inspect it, seems about reasonable. And one of my other favorite functions with raster is what's called the reclass. And if you look at the histogram that we had, there's all these different kinds of pixels that for our purposes are probably the same. I just really want to divide my raster data into black and white pixels. So now I have two copies of this. I have the original, and then I have what I call the reclassed. And once you reclass things, you can, whatever you turn to no data, you can apply this function called the min convex hull. And what that will do is it will keep on shrinking your raster tile until it hits a non-data pixel. And so this is useful if the data you have, your raster data is mostly white noise, like you have lots of ocean and you don't really care about that. You can shrink the tile down to just the internal area. And you could see that when you compare the width and height of the two, the reclass one has a much smaller width and height. And one of the more common things to do with raster is to vectorize it. So because vector data is generally simpler to work with because it's really just, it's either on or off data. And so if I vectorize my raster, since I reclassified it, all that white space, I set it to basically, I don't care about it data. And so what I'm left with is the black part of my data. And if I zoom in really closely, you'll see that it's very pixelated. And then there's also another function called resize. And the only reason I'm doing this is because I don't want to have to deal with the dimensions that this raster was. For my purposes, I'm going to treat this as 4 tiles across and 3 tiles down. And I'm going to create a stencil set with it. And what is this? I'm basically taking those tiles, the 4 tiles, 3 tiles down, and I'm going to convert them to separate rows using this function called sttile, which is a set returning function that takes your rasters and chops it, making the width be this and the height be that. And it'll soon become clear why I'm doing this. Okay, so if I look here, I can look at just one of these. So let's say I looked at the E. You see it's only 1. So I've basically chopped up my my raster into, and then vectorized it. But I have this annoying square around it. So to fix that, I am going to use the stdump function, which is part of PostGIS. So I'm doing 2 things. I'm getting rid of the white space because I know that anything that has a width of greater than 4,000 is that square that I don't want to keep. And then I'm also smoothing it out so that it doesn't look quite as pixelated. You can also do a similar thing using the ST Simplify Polygon Hull, which is kind of the same class of functions that Martin had talked about. And that, I think, works a little bit better. Okay, so now I'm just going to back update this. And I am going to do what I call creating a font set. So the ST letters function has embedded in it a font set. But when ST letters was created, many people asked, how do I create my own fonts? How do I inject other languages in there? To which Paul said that wasn't his problem. And so one way you could do it is to create your own. You could do it with raster, although they're cleaner ways of doing it. But this is just one way to demonstrate how you do it with raster. And the other thing about the ST letters is it uses a not so well-known format called the tiny WKB format, which is a pretty lightweight format for storing vector. And so if we try that now, we can pass to ST letters our font set, which has to be a single JSON record. And we can say hello using our stencil set. Okay, one of the other extensions that was discussed was the OGR FDW. And this one's similar to raster, builds on top of the GDAL, except it uses the vector component of GDAL instead of the raster component. And what's great about this foreign data wrapper is not only does it handle spatial data, but it also handles non-spatial. So you can, for example, feed it Excel spreadsheet or workbook or CSV. You can even feed it a whole folder of CSVs, and it will, with the power of GDAL, automatically make sense of the columns and create tables out of it. And similar to the raster functionality, the PostGIS raster, it's dependent on what GDAL it was compiled with. So there is a function. I think this tells you which version of GDAL. Okay, so this one's compiled with GDAL 3.71. And again, it depends on which drivers GDAL was built with, because if you have the barest minimum of GDAL, you don't get as many supported formats. But if I look at the supported formats of my GDAL, I see there's 80. And one thing I don't like about this function, I don't know who wrote it. I mean, it's nice that it tells you the formats, but if you compare it to the PostGIS raster one, first of all, whoever wrote this had the care to have separate records, right? Whereas, and it gives you all this extra information without thinking about it. Whereas the guy who wrote that one decided he was too lazy, and all he gave you was a array. This array tells you nothing about, it tells you what formats you can read, but unlike this, it doesn't tell you what you can write. And yes, OGR FDW can write formats. It can update files. So you have to resort to this, unnesting your array and ordering it to make sense of it. But anyway, that's my gripe about it. At least I should be happy that I at least know what formats I can read. So GDAL also has this neat functionality, which Brian already showed. How do you read a file from the web? And so I'm going to take Randy's idea and Brian's idea, and I am going to read a geo package format that's zipped up, gzipped up to be exact. And I picked this from here. Actually, where is it? I picked it. Except I couldn't read it from there because it does some sort of redirect, so it didn't work as nicely. So I just copied it locally to my server just to test it out. And there, I usually put this data into a staging schema because usually I use this as an ETL tool. I don't use it generally for reading, and especially with a HTTP, you probably don't want to be live reading that, because every time you call a HTTP, it's basically doing a repull of the data, which can be very slow. And so this OGR all is a catch-all that says bring all the tables that are in my server into the database, link them in. And there's only one in this case. And so, yeah, there's only population. So yeah, that's what you could do with OGR, and you could read all those formats. And then the other extension that comes with PostGIS is called the address standardizer. And it's basically a rule-based address standardizer. You feed it a set of tables, a lex and a gas, and a set of rules. And based on the rules, it determines what the preferred format is. So if I were to take this address, it would break it out. It would break out the address into the different components. And the address standardizer data.us is just an extension that contains nothing but data. It contains these three, and it's more of a, this is an example of how you create these tables, but you can massage it for your own needs. Though, admittedly, I've only used it in US, so your miles may vary with other countries. And then recently in 3.4, I introduced this function called debug standardized address. And the reason for that is because creating rules is very hard. It's hard to make sense because you don't know how the standardizer is converting your words into tokens. So the idea behind this was to be able to peek into what it's doing with the tables so that you could fix up the tables. And also, you know, coming up with the rules that it decided on. The first rule is always the one that wins and the one that it outputs in the standardized address. And since it's JSON format, you can expand it however you want to see all the rules. You can expand the tokens. And I think I've run out of time. Paul?
You've got a whole minute left. Regina,
I have a whole, okay.
seconds on the table.
Oh, all right. Okay, so let me do the PostGIS Tiger geocoder. So the Tiger geocoder is a geocoder, and this is very US centric because it's based on the census data. And I don't have too much time to go over it, but if you wanted to load data, you can load it here. And then the 3.4.1, I'll include a patch to make it load the recent Tiger census data. And this will load all the data from Tiger useful for geocoding, but people tend to use it for statistics too. So it can also load the census tract, block group. Is there anything else? And tabulation blocks for population analysis. Okay, now I'm done, right?
You're done. All right. Thank you, Regina. Do we have any questions in the chat? I guess, like, I know you've been playing with the address standardizer a bit lately, and have you made it better for Canada too?
You know, there's some stuff that's hard coded in it that I think we have to get rid of. And there's a note that says we really should move this out of the hard coding, which I haven't looked at.
Okay.
But I think it's pretty good for Canada. It actually works fairly well.
Yeah, but French? Yeah.
No, probably not.
No, okay, not. Yeah, that's where things, the order of things and the canonical expectations get broken down.
Yeah, but it might, I think once we move those other things out, then it's conceivable to set up a set of rule table and a canonicalization, because really the rule determines what the how it stuffs each piece, and then the tokenization determines what part is what.